Hello everyone. We are going to continue from the last lecture. That is, we have seen the two types of roots of the polynomial equation. That is, simple root and multiple roots. Then we are going to continue with this iteration methods based on first degree equations. First of all, I would like to recall that what are iteration methods. There are two types of methods, that is direct method and iteration method. In the direct method, you have a particular formula and you have to just put the values and get the answer, or you can say derive the equation and you will get the root of the equation. तो आपको क्या करना होता है कि उसमें वैल्यू पुट करना होता है और आपको आंसर मिल जाता है डायरेक्ट मेथड में. बट इन द इटरेशन मेथड we have it is like successive approximation. First of all, you are having one or two initial approximation, and from that initial approximation you just started calculating the values using the iterative formula, and then you get the approximations like x0, x1, x2 and xn, so on. सो ऐसे करके हमें वो इटरेशंस मिल जाते हैं. सो दैट इज कॉल्ड इटरेशन मेथड्स. You have to stop up till you get desired result. So this is called an iterative methods. So we are going to study iteration methods based on first degree equation. We are going to study the following numerical methods to find the roots, or you can say zeros, of the algebraic and transcendental equations. So first is Newton-Raphson method, second one is secant method, third one is regular Poisson method, and fourth one is iteration methods. So let us start one by one. Let's have the first one, that is Newton-Raphson method. So as we say Newton-Raphson method, we call it as Newton's method, or this is also called as tangent method. मैं आपको बताऊंगा कि tangent method इसको क्यों बोलते हैं एक अगले 5 मिनट में. So see here that this method is also called as tangent method, in which we approximate the curve near the root by straight lines. So let's have look at this diagram. तो अगर आपको डायग्राम दिखाई दे रहा है तो आप देख सकते हैं कि देर इज अ कर्व. दिस इज द कर्व एफ ऑफ एक्स, ठीक है, एंड वी आर गोइंग टू approximate that curve and to the root alpha. So you can see that this is the root alpha, original root alpha. So we are going to approximate. So let's start. Let x0 be the initial approximation to the root f of x equal to 0. So we have considered this x0 as initial approximation to the root. Then p x0 f of 0, that is f0. हाँ, वो जो f0 है you can call it as f of x0, which is the point on the curve. ये जो curve है, so this is the curve and the point on this curve is called that is f of x0. So you can call it as f0. So it is the point on the curve, and now what we have to do is you have to draw a tangent to the curve at the point P. एक tangent आपको निकालना है जो point P को टच करके जाएगा और x एक्सिस को कट करेगा. So now what we have to do is we approximate the curve in the neighborhood of root by the tangent to the curve at the point P. Just now I told you that you have to draw a tangent which will pass through point P, which will cut to the x-axis. So the point of intersection of the tangent with the x-axis is taken as next approximation. मतलब क्या है कि जो point of intersection है, जो point of intersection है और ये जो है point of intersection with the x-axis and tangent, ठीक है, that will be your फर्स्ट अप्रोक्सीमेशन टू द रूट से x1, उसको कहेंगे हम x1 कहेंगे. So what you have to do is, this is not your original root, this is not your original root alpha, so we have to approximate it, we have to approximate it, we have to go this method again and again, we have to follow this method again and again. ठीक है. So क्या करना है हमें? So again you have to consider point, another point, say p1, uh, which will, you just take the perpendicular to this and point on this curve. So that will be p1, say x1 f1 or f of x1. So you just consider the point, and then again you have to draw a tangent to that point p1 and cutting to the x-axis. ऐसे करके आपको पॉइंट निकालना है, टेंजेंट निकालना है. सो उसके बाद then we have to continue this process until we get the desired answer. So let us continue with this. Now we are going to derive the equation for the Newton-Raphson method. So the equation of the tangent of the curve y equal to f of x at the point fp, that is x0 f0, is given by, so this is the equation of straight line. We know all this, y minus y0 and x minus x0 into m. So what is this f dash of x0? So we know that this is the slope of the tangent line. So here we can see that this is the slope of the tangent to the curve p. So when we set y equal to 0 and solve for x, we are going to get this x equal to x0 minus f of x0 divided by f dash of f of x0, where f dash of x0 is not 0. So हमें क्या मिल रहा है कि अगर हमने y equal to 0 डाला, तो what we are going to get, that ये f dash of x0 है वो इस साइड में जाएगा, so that will be in the denominator, और बाद में x माइनस एक्स जीरो मिलेगा, तो एक्स जीरो ये माइनस एक्स जीरो है, इस साइड में आएगा, तो वी आर गोइंग टू गेट दिस एज अ प्लस. सो x इक्वल टू एक्स जीरो माइनस एफ ऑफ एक्स जीरो डिवाइड बाय एफ डैश ऑफ एक्स जीरो. वो एफ डैश ऑफ एक्स जीरो मस्ट बी नॉन जीरो फर्स्ट ऑफ ऑल. द नेक्स्ट अप्रोक्सीमेशन टू द रूट विल बी गिवन बाय. सो वो जो हमें ये मिला है, अप्रोक्सीमेशन मिला है, सो यू कैन said call it as first approximation. So that is x1 equal to x0 minus f of x0 divided by f dash of x0. So when we are going to continue with this, मतलब क्या करना है आपको कि x1 is not your original root, desired root. So what you have to do is you have to continue the process of approximation, and then you have to you will get uh, a set of. So here x1 is not your desired root, so what you have to do is you have to continue with the approximations, say, let's say like x2, x3 and xk and xn and so on, so that you will get your desired answer. So the general method, or you can say general uh, formula for this will be xk plus 1 is equal to xk minus f of xk divided by f dash of xk, where f dash of xk is non-zero. So this is the iterative formula to find the root of the equation, or you can say root of the polynomial equation, which will be transcendental and algebraic equation. So this is also called as, so this is called as Newton-Raphson method, or you can say Newton's method. So we are going to continue with the example. So we have seen Newton-Raphson method. Now we are going to study one example based on that. So let's have example. So this is the example. Perform 4 iterations of the Newton's method, that is Newton-Raphson method, to find the smallest positive root of the equation f of x equal to x cube minus 5x plus 1 equal to 0. So you can see that there is no initial approximation given. So still we can find the initial approximation. We know that only one initial approximation is enough for Newton-Raphson method. So I will go back and show you again the our example, or I will say formula for finding the root of the equation by Newton's Raphson method. So this is the uh, I'll show you. Yeah, so this is the formula to find and uh, root, or you can say iterations using Newton-Raphson method. That is xk plus 1 is equal to xk minus f of xk divided by f dash of xk. So you can see that we need a function at that point, f of xk and f dash of xk. So we need derivative of that function and its derivative. So let us find the root for this equation, that is x cube minus f of x plus 1. First of all we have to find the derivative of this. So we will find the derivative. I have not written here explicitly, but you can find it easily. That is x cube minus 5x plus 1. This is the f of x. So f dash of x will be 3x square minus 5 and plus 1, that is one derivative is 0. So 3x square minus 5, 3x square minus 5. So this is the derivative f dash of x. Now we have to find the initial approximation. So how will you find that initial approximation? So there is a theorem that we will you going to use. That see there is one theorem, that is if f of a into f of b is less than 0, if f of a into f of b is less than 0, then the root lies between a and b. Then the root lies between a and b. So ये थ्योरम जो है वो हम यूज़ करने वाले हैं। तो ए एंड बी ऐसे फाइंड करना है हमें कि उसका एफ ऑफ ए इंटू एफ ऑफ बी वो लेस देन ज़ीरो चाहिए, दैट इज नेगेटिव चाहिए. So let us find out a and b, such a and b. So see here we can see that we have f of 0 equal to 1 and f of 1 equal to minus 3. तर इधर आप देख सकते हैं कि हमें f of 0 1 मिला, that is positive, and f of 1 is negative, right? So f of 0 into f of 1 will be surely less than 0. तो ये हमें दिखा देता है कि the root lies between 0 and 1, 0 and 1. So the smallest positive root lies between in the interval 0 comma 1. Okay, so applying the Newton's method we obtain. अभी न्यूटन्स मेथड हमें पता है कि एक्स के प्लस वन इक्वल टू एक्स के माइनस एफ ऑफ एक्स के डिवाइडेड बाय एफ डैश ऑफ एक्स के. सो नाउ वी कैन सी दैट एफ ऑफ एक्स के प्लस वन इज इक्वल टू एक्स के माइनस एफ ऑफ एक्स के. सी यार एक्स की जगह है हमें एक्स के डालना है. सो एफ ऑफ एक्स के, ठीक है, एफ ऑफ एक्स के. सो एनीवेयर यू कैन सी एक्स, सो यू जस्ट रिप्लेस इट बाय एक्स के, you just replace it by xk. So xk cube, here it is, minus 5xk, here it is 5xk, and plus 1. Okay, and divided by, I told you in the beginning that f dash of x we need. So I told you that we have discussed that xk f dash of x will be 3x square and minus 5, 3x square minus 5. So here it is 3xk square and minus 5. We have to replace x by xk also here. And when you solve it, okay, here xk minus and this whole thing is there. So just when you solve it, okay, after solvation you will see that 2xk cube minus 1 and divided by 3x square minus 5, and k is from 0 1 2 and so on. ओके, सो अभी हमें ये इटरेटिव फॉर्मूला मिल गया है. नाउ व्हाट यू हैव टू डू इज यू हैव टू जस्ट पुट द वैल्यू k इक्वल टू 0 and k equal to 1 and 2 and so on, so that you will get the approximations, iterations. So let us consider, so I have considered now that this initial approximation as x0 equal to 0.5, because 0.5 lies between 0 and 1. सो आई कैन कंसिडर एनी वैल्यू, यू कैन कंसिडर एनी वैल्यू, कौन से भी आप चूज कर सकते हैं, नॉट ओनली 0.5 बट 0.1, 0.2, 0.9, कौन से भी ले सकते हैं, कोई ये नहीं है। ओके, सो वी हैव द फॉलोइंग रिजल्ट्स। सो देखते हैं अभी क्या मिलता है। सो एक्स के प्लस वन, सो आई टोल्ड यू दैट के इक्वल टू जीरो पुट करना है हमें। सो जस्ट पुट द के इक्वल टू जीरो ओवर हियर। हाँ, इसमें पुट करेंगे तो के प्लस वन है, सो एक्स वन। ओके, सो एक्स वन विल बी इक्वल टू, तो अभी इधर के इक्वल टू जीरो पुट किया है, सो टू एक्स जीरो क्यूब, राइट, टू एक्स जीरो क्यूब माइनस वन डिवाइडेड बाई थ्री एक्स जीरो स्क्वायर माइनस फाइव, ऐसा होगा। सो जस्ट पुट द वैल्यू एक्स जीरो इक्वल टू, just we have seen that we have considered x zero equal to 0.5, so 2 0.5 का क्यूब माइनस वन डिवाइडेड बाई थ्री, 0.5 का स्क्वायर एंड माइनस वन इक्वल टू, अभी अगर हम ये कैलकुलेट करेंगे कैलकुलेटर में, साइंटिफिक कैलकुलेटर में, सो हमें मिलेगा इधर 0.176471. So this will be your first approximation to the root. This will be your first approximation to the root. So ये अभी x1 मिला है, अभी ये x1 अभी हमें यूज करना है नेक्स्ट अप्रोक्सीमेशन में। So let's have k equal to now 1. Let us have k equal to 1 in this equation. So in this equation, so k equal to 1, तो 1 plus 1 2 हो जाएगा, so x2 will be equal to, and here also the changes will be there, so 2x1 cube minus 1 and 3x1 square minus 5. So here it is, I have written, then it is equal to 2. So x1 is, you know that we have found that x1 is first approximation, that is 0.176471. so ये पुट करना है हमें इधर भी और इधर भी, ठीक है। सो आफ्टर कैलकुलेशन, सो वी विल गेट 0.201568, okay, so now we'll get the second approximation to the root. Okay, so similarly we can find x3 and x4 and so on, x5 and so on. Okay, so you can see that x3, after solving, so yeah, you have to just put the value k equal to 2 over there, okay. So you will get x3 equal to 2x2 square cube minus 1 and 3x2 square minus 5. So you just put the value x2, x2 की वैल्यू पुट करनी है इधर, तो आपको ये मिल जाएगा, और आफ्टर सॉल्विंग ओके यू विल गेट 0.201640। तो और फिर से अगर आपको ये करना है, अप्रोक्सीमेशन करना है, तो आपको करना सेम मेथड से जाना है। सो सी इफ यू सी द डिफरेंस इन द approximations, x2 x1 was 0.1764, x2 is 0.2015, बाद में आप अगर देखें तो 0.2016, 2015 2016, ओके, सो क्लोज आ रहा है। तो अभी और एक कर सकते हैं आप, तो x4 लिया, तो x4 का आपने अगर सॉल्व कर लिया, सो यू विल गेट 0.201640। तो you can see that significantly it is closer, or you can say it is equal. x3 and x4 are you can say those are equal, so you have to stop the iterations and your answer will be the root of the, you can say, this equation will be 0.201640. okay, so this is the answer of this equation. Okay, so we will continue with the next point.